What we're going to be learning about today is the sine function. So this is sort of an introduction to what it is and where it comes from. We're going to look at the sine function in degrees and in radians. So what we're going to use to get our sine function is a thing called the unit circle. So let's look down at this unit circle here. All right, this is a more simplified unit circle. Usually you start here, this is 0 degrees, which is also 0 radians, and then it goes up in a third here, and then it goes up to a fourth, pi over 4, and then goes from there. Or sorry, it goes up to pi over 6, pi over 4, pi over 3. You don't really need to memorize this, but I'm just going to show you how this works. You will use this more in pre-calculus and things like that. So what we're going to do is we're going to use the fact that for the unit circle, the x values are cosine and the y values are sine. Okay, so starting here at the very beginning at 0 degrees, so we're looking right here, the y value is our sine. So at 0 degrees, that's our start, sine is at 0. So this is our y value that we're looking at. So for each one, we're going to take this for that one, then we're going to do this one, all the y values, 1, root 2 over 2, 0, root 2 over negative root 2 over 2, negative 1, and negative root 2 over 2. So these are all the values that I'm going to plot there. And we're going to keep in mind that root 2 over 2 is about 0.707. So let's go up to the top. For the first one at 0 degrees, so it's looking here, at 0 degrees, it's 0. So at the very top, in degrees, this is 0 degrees, we have the point 0, 0. Okay, then moving up, so I'm skipping these and just kind of going to some important ones. At at 45 degrees here, it's going to be root 2 over 2, which is about 0.7. So at 45 degrees, it's going to be at 0.7. So here's 45 degrees, and we're going to be at 0.7, which let's say is about right here. All right, 0.7. Okay, then at 90 degrees, so that's right here, at 90 degrees, it's going to be at 1. Okay, so at 90 degrees, we're going to be at 1. Then at 135 degrees, we're going to be at root 2 over 2 again, which is 0.7. So at 135 degrees, that's in here, we're going to be at 0.7. Then at 180 degrees, we're going to be at 0. Then if we go down to 225 degrees, we're going to be at negative 0.7. So let's say negative 0.7 is about here. Okay, so we're going to be down here. And then we're going to go to 1 at, or negative 1 at 270. Right here. And then here at 315 degrees, it's going to be at negative root 2 over 2, which is negative 0.7. So we're back here again. And then at 360 degrees, so that's making a complete circle around, we're going to be at 0 again. Okay, so here we're going to be at 0. All right, so here we have this wave that looks something like this. All right, now let's look at the left-hand side. So what would happen if we went to negative degrees here? All right, going in the positive direction is like this. So now we're going to go in the negative direction this way. Okay, so starting at 0, this is our 0 degrees. Negative 45 degrees would be right here. Okay, so at negative 45 degrees, we're going to be at negative 0.7. So up here, we're going to be at negative 45, we're going to be at negative 0.7. Then at negative 90, so this would be negative 90 here, coming this way, we're going to be at negative 1. Okay, and then it's going to follow this pattern again. It's going to go back to negative 0.7, then to 0, then up to 0.7, then up to 1, then 0.7, then 0 again. So this wave will actually continue as many times as we're going to want to go around the circle. All right, it's going to continue as much as we want. So this thing goes on forever in that direction. It also goes on forever in this direction. So this is how we get our sine function from the unit circle. All right, now we're going to look at this in radians. It's pretty much the same thing, except now our y-axis, or our x-axis, instead of being in degrees, is going to be in radians. So let's look here. From the unit circle, we're going to start at 0 again. So this is our thing in radians. At 0, it's going to be 0. All right, between pi over 2 and 0 is actually our pi over 4. Okay, so this is our pi over 4. Pi over 4 is the same as 45 degrees, so that's going to be our 0.7. Let's say our 0.7 is here and here. All right, so we're going to go up to this. Then at our pi over 2, which is at 90 degrees, is going to be 1. And you can see that this is going to follow the exact same pattern, but now we're just in radians. Okay, so it's going to go down, and then it's going to go down to negative 0.7, here, here, and here. It's going to be the exact same wave, just with a different x-axis. All right, and then it's going to follow the exact same pattern if we go in the backwards direction. So here, this is going to go to negative 0.7, negative 1, negative 0.7, 0, positive 0.7, positive 1, 0.7, and 0. All right, so this is our sine wave that came from all the y values of our unit circle. Again, you don't need to memorize the unit circle, but you do need to know that sine comes from the unit circle. Okay, so what we're going to do now is we're just going to look at a few properties of the sine function. This is our parent function. So the first thing is that we need to establish what one full wave is, okay? So one full wave is starting here. See, I'm on an upward slope here. If I go to the right, I get back to this point right here, okay? And the same up here. From here, starting at this upward slope, I don't get back to that same place until right here, okay? This is what we call one full wave, okay? So this is one full sine wave right here, and one full sine wave right here. So it happens in 360 degrees or in 2 pi in radians, okay? So what we're going to do is down here, one full wave, right? One full wave occurs in 360 degrees, or we could say that this is in 2 pi radians. All right, one full wave occurs in 360 degrees or in 2 pi radians. The next thing that we're going to look at is the amplitudes. That's just how high up and down it goes. Okay, how high up and down it goes. From the middle, okay, so from the middle here, this is going up, only up 1, and it's only going down 1. Okay, so each time it goes up 1, and then down 1, down 1, up 1. It's only going up 1 and down 1. Okay, so the amplitude of the sine wave is going to be 1. So this is how high up and down it goes. It's just 1. All right, and the wave starts in blank of the wave and blank. Okay, so let's look here. Each wave is starting on this slanted part of the wave on the y-axis. Okay, so we're starting here at the slant. This is sort of in the middle of one of the waves. Okay, so it's starting at 0, 0. We call this the middle of the wave because it's in a place sort of like this. Okay, this is half of a wave, this is another half of a wave. So it's starting in the middle of the wave on the y-axis. Okay, starting in the middle of the wave on the y-axis. So the wave starts in the middle of the wave. at the y-axis. All right, let me just zoom out a little bit. All right, starts in the middle of the wave at the y-axis. And then we're just going to answer this last question. The wave is cut in half by the blank axis. Okay, so we're asking, when is it cut in half? All right. Looking up here, we're talking about cut in half this way. So you can see that this is being cut in half right at this here. Okay, so here and here, this is being cut in half. All right, so it's being cut in half by the x-axis. All right, cut in half by the x-axis. All right, so properties of the sine function. One full wave occurs in 360 degrees, which is the same as 2 pi radians. The amplitude, that's a new word, is 1, so it goes up 1 and then down 1. And the wave starts in the middle of the wave, so it's starting at the slant, and then this is at the y-axis is where it's starting. And then the wave is cut in half by the x-axis. All right, so what the work is going to be for today is just making sure that you understand these questions. So you can use this to help you with the work today. Please let me know if you have any questions at all. Tomorrow we're going to be working on the cosine function. All right, you guys know the drill. Message me and remind if you need any help. I hope that you guys have a great day. Bye.